Hello everybody, my name is Marcia and I am about to explain what appears to be a non-trivial problem with my alternative interpretation of the Croatian names of places, about which I've already made a few videos and about which I published a paper called Etymologia Karašica in two peer-reviewed journals. First, special thanks to a Discord user called RYWKO5626 for informing me of this problem. In this video, I am going to presuppose some familiarity with my theories as I explained them in my earlier videos. Explaining them again would make this video much longer than it needs to be. So the error was in my assumption that the entropy of phonotactics can be estimated as 2 times the first order entropy minus the second order entropy. That would be true if consonant pairs, potentially separated by a vowel, that occur at the beginning of a word are strongly correlated with consonant pairs that occur in the middle or at the end of a word. That's not true, and for languages such as Croatian and English, whose phonotactics allows for many consonant clusters at the beginnings and the ends of the words, that's especially not true. Word initial and word final consonant clusters are governed to a large extent by the law of sonority. The law of sonority says, among other things, that consonant clusters common at the beginning of a word are unlikely at the end of a word. For instance, many languages would allow a word to end with the LT consonant cluster, as in the English word melt, but hardly any language would allow a word to start with that consonant cluster. For that reason, in languages such as Croatian, the collision entropy of the consonant cluster at the beginning of a word is around 1 bit per consonant pair, smaller than the difference between first order entropy multiplied by 2 and the second order entropy. Now, at the first sight, the difference of 1 bit per consonant pair might not look like much, but given that we are talking about logarithmic scale, it's a lot. If you put into the birthday calculation the simulated number of days in a year to be 64, you get a p-value of 1 in 17. But if you put 32, which is 1 bit lower, you get a p-value of around 75%. And indeed, this Node.js program, which analyzes the tokenized Aspel word list for the Croatian language and makes simulations based on that, suggests that the p-value of that KA pattern in the Croatian river names is around 86.51%. Now, of course, a question one might ask is whether this is true only because we speak a language full of word initial and word final consonant clusters. And the answer is it partly is because of that, but it's not entirely. The word initial and word final consonant clusters are not strongly correlated even in the Hawaiian language, which doesn't allow for any word initial nor word final consonant clusters. Here is a Node.js program that measures the correlation between word initial and word final consonant pairs. Here is what the program outputs if we give it the Croatian Aspel word list. The correlation is around 1.18. And here is what the program outputs if you give it a long text in the Hawaiian language. The correlation is around 0.44. While the correlation is higher than in Croatian, it is not approaching 1. So what I believe I've learned about science from all of this. Hey, listen, it seems to me that computer science in general and information theory in particular give people who know them the ability to appear to mathematically justify flawed intuitions. That includes, but it's not limited to, the flawed intuitions we all have about how languages work. That is, if studying computer science is not building those flawed intuitions in the first place. For instance, in our cybernetics classes, we are taught that if some system is slightly less than an integral, it is probably an IT1 type system, which is perhaps true in computers, but if you try to apply it to something else, it will mislead you. A few months ago, I made a video about how that way of thinking misled me into thinking that methane in the atmosphere with respect to our methane emissions is an IT1 type system, which it isn't. Or, well, this Kea pattern in the Croatian river names. Basic information theory appears to be applicable here. It even appears to give relatively precise numbers, that the p-values between 1 in 600 and 1 in 17, but those numbers are widely wrong, and so on. Second thing I learned is that just because people give you offered responses, that doesn't mean your argument is correct. For instance, the first response I received on 2 internet forums was, what if nouns in the Croatian language have a much lower collision entropy than the rest of the words in the Aspel word list? That to me seemed like a blatant ad hoc hypothesis and just made me more convinced that my theory is correct. That's not the right way of thinking. And the third thing I learned is that this way of thinking, that mathematics is the difference between science and BS, is not true in social sciences. In fact, it may even be the opposite. Because quite often, society behaves in the opposite way than mathematics predicts. The Markov chain appears to rather clearly predict that the consonant pairs in the beginnings and the ends of the words would be strongly correlated. But as I have shown, it isn't so. People are saying that engineering schools cannot be indoctrinations because most of what they are teaching are merely heuristics to solve mathematical problems. I think now that they might be the worst form of indoctrination because people are so certain they are not indoctrinated. That's all for this video. Thank you for watching.